Okay, so this is a introductory video on null and alternative hypothesis. It's many of the academic studies that we do concern us testing a claim. So how do we, as an introduction, how do we look at null and alternative hypotheses? Think of it like a jury trial when somebody is up for murder. You could either be not guilty or the alternative is you're guilty. So if you were to frame that in a null or an alternative hypothesis statement, the null would be your proof that the suspect was not guilty or the whoever was charged was not guilty. If you have enough evidence to prove that the person is guilty, then you would reject the null. You always say it that way. You reject the null or you accept the null. You would reject the null and you would accept the alternative hypothesis. But remember, to value the alternative hypothesis or to accept the alternative hypothesis by rejecting the null, and it gets a little confusing, but try to remember those terms. It's the non-null value. You have to remember that. You have to have enough evidence that would point toward the person being guilty. And we know in our jurisprudence system, and that's why I'm using this example, that it's got to be beyond a reasonable doubt. So the statistics in the case of a study or the evidence in the case of an investigation has to be so unique that you would say I have to reject the not guilty plea. I have to accept the alternative plea, which would mean that you would fall somewhere over here in the spectrum of the normal distribution in order to accept the alternative hypothesis in this case. Generally speaking, on statistical analyses, we use about a 5% confidence interval, which means that if the statistics that we have derived have a probability that it could only happen within 5% or less, 5, 4, 3, 2, or 1, we would reject the null and say, this evidence is so, again, unique that this person had to be guilty. So for instance, I like to use an example. If there's a murder in the middle of the quad at a college event, and they come back and they bring in a suspect, and they said, well, the suspect was wearing, and we know everyone identified the perpetrator as a person wearing a school logo. Well, if I go out and determine that, I go and send the detectives back out and say, we'll find out how many people were in school logos that day. And if they come back and say, well, approximately 35%, well, that means I'm not going to accept that. I won't hold that suspect. Why? Because if it's a 35% confidence, that means 35% of the time I would be wrong on this. In which case, and we'll talk about that in a minute, we'd have an issue because now we would be holding a person or convicting a person where it could have been where the possibility of being wrong is pretty significant. But let's say I send them back out there and they find a footprint and it's a sneaker, and they come back and they say, well, only 1 out of 1,000 people have a sneaker like this. Well, now we're well below, say, a 1% confidence interval. We're actually 1/1000th. So at that point, where our evidence is unique enough or significant enough that we would reject the null and accept the alternative hypothesis. But we always have to worry that we're making an error. And in the next video, I'll talk about the significance of type 2 and type 1 errors, the errors that we can live with and the errors we really do not want to live with. But once again, and this can get a little confusing, whenever we talk about a claim, we want to set the claim up. So if somebody say for instance, an auto dealer says, the average sale of my car on my lot is $25,000, and we believe it's lower than that. Well, then his claim would be that the sale equals $25,000. The alternative would be it doesn't equal $25,000. So in that case, we'd set it up as the null is, the alternative is it equals $25,000. The null is it doesn't equal $25,000. In which case, if our statistics prove close enough, if the average sales we've taken in a sample over many different samples is close to 25,000 with a small standard deviation, well, then we would accept the alternative hypothesis, right? Because now we have enough evidence to prove that, and we put a 5% significance on it, we'd have enough evidence to prove that the alternative is acceptable. But if the numbers are way low or even high, we would accept the null and reject his alternative claim or the alternative hypothesis. Now remember one last thing, and this has to do even with the COVID trials. You have to set a confidence interval that's commensurate to what you're studying. If I'm just looking at a study of, the sales of cars on a lot, I could live with a 5, even a 10% confidence interval because I'm wrong. What does it imply? Well, if I have a 10% confidence interval, I'm going to be wrong 1 out of 10 times. I mean, I have to live with that. Or 5% is going to be 1 out of 20 times, but I can live with that because if the numbers were off a bit, it just means the claim was off. But if I'm doing a life and death study or a murder trial or something like that, where being wrong has profound effects, like the COVID vaccine, well, then I might want to set my confidence intervals at below 1%, because the idea of me being wrong could be devastating. So that's kind of an introduction, and we'll be doing more on this, but it's an important part of statistical study to set up your study as the null and the alternative, and to always remember that we either accept the null and reject the alternative, or we reject the null and accept the alternative. But we set it up as a claim versus the alternative of a claim. And we'll be doing more. In the next video, we'll be doing type 1 and type 2 errors.